All right, today you're going to look through some additional practice problems on pages 11 and 12. Make sure you've had a chance to solve those problems, and then let's go through and correct them. So Jared and Pedro walk 1 mile in about 15 minutes. You should be recognizing that as a proportion, 1 mile over 15 minutes. So about how far can they walk in 90 minutes? Make sure we're putting 90 minutes right there on the bottom with 15 minutes. So I'm going to look for a scale factor. 15 times 6 makes 90. 1 times 6 makes 6. So I think they'll walk about 6 miles in 90 minutes. About how far can they walk in 65 minutes? Again, I'm going to start with my same proportion. 1 mile over 15 minutes equals 65 minutes is going to go on the bottom with the other minutes. And I'm going to look for this scale factor here. So 15. To get to 65, this is a little bit more complicated to figure out. This is going to be 4 1/3, and if you divide 65 by 15, you can find that value. And when I multiply 1 times 4 1/3, I get 4 1/3 of a mile. It's also okay if you wrote that as a decimal, 4.3. You could even put that little line over the 3 to show that it's a repeating decimal that goes on forever. For problem B, swimming 1/4 of a mile uses the same number of calories as running 1 mile. So setting this up, I'm thinking about swimming over running. And if I swim 1/4 of a mile, so that's 0.25 of a mile or 1/4 of a mile, that's the same as running 1 mile in terms of the calories. So now Gilda runs a 26-mile marathon. So again, I got to make sure that I'm putting the running with the other running. So the 26 is going to go on the bottom, and I'm looking for a scale factor. So 1 times 26 makes 26, and then 1/4 of 26 would be 6.5. And so if I swim 6.5 miles, that uses the same amount of calories as running 26 miles. For B, Juan swims 5 miles a day, and we want to know how many miles would he have to run to use the same number of calories from swimming. So again, swimming over running. Swimming uses, if I swim 0.25 miles, 25 hundredths of a mile, I burn the same amount of calories as running 1. So if I swim 5 miles, you'll notice the 5 is going on the top because I'm talking about swimming. I want to know how much or how many miles I'd have to run. So I'm looking for this scale factor here, and if I do 5 divided by 1/4, I'm going to find this scale factor, which in this case is 20, and then 1 times 20 would be 20. So I'd have to run 20 miles, or he would have to run 20 miles, to use the same number of calories from his 5-mile swim. In problem C, we're talking about light bulbs. So approximately 2 out of every 1,000 light bulbs are defective. So 2 defective light bulbs out of every 1,000 light bulbs. I'm just making up some units here so I can keep track of what's what. So if Americans buy more than 1 billion light bulbs every year, about how many of these are defective? So I don't know how many are defective, but the amount we're buying is over 1 billion. Make sure you have enough zeros on there. And so I need to find this scale factor. 1,000 times what makes 1 billion? The scale factor is 1 million. 1,000 times 1 million makes 1 billion. And then 2 times 1 million would get us 2 million. So out of the 1 billion light bulbs, we're saying that around 2 million of those are defective. In problem D, we're talking about buttons. So we pay $18 for 12 dozen buttons. I'm going to use dollars and D for dozen. So you might be noticing already you could scale that ratio down, right? You could make that 9/6. You could divide by 3 for both of them and make it 3/2. Right, so you can kind of play around with that ratio if you want to, if you don't like it in that form. Those are all equivalent. So how much do 4 dozen buttons cost? So $18 for 12 dozen means how much money for 4 dozen? So if I look at these guys over here too, I might notice that 3/2 would be a pretty simple ratio to scale up and turn 2 into 4, right? Since 2 times 2 would make 4, 3 times 2 would make 6. So it should be $6 for 4 dozen buttons. Another way you could have found that is multiplying by 1/3, which is the same as dividing by 3, right? But be aware there's lots of different ways to find the equivalent ratios involved, right? Scaling up, scaling down. All right, finding next, how much do 50 dozen buttons cost? So again, $18 for 12 dozen. How much money would 50 dozen cost? So now I'm going to look at this piece and I'm going to think about how do I go from 12 to 50 to look for my scale factor. And this is kind of a tricky scale factor. 50 divided by 12, right? Again, this is like the image divided by the original. 50 divided by 12 would give me 4 and 2/12, which is 4 1/6. So this scale factor is 4 1/6. And so on a calculator, when you find this value, it's really good if you can just leave that value on your calculator screen and then multiply straight by 18 without rounding. And when you do that, 18 times 4 1/6, you will find the exact answer of $75. Again, if you scale the ratios, that might help you think about it as well. All right, now D, how many dozens of buttons can they buy for $27? So $18 for 12 dozen. What about with $27? How many dozen can we buy? I'm going to look at one of these other ratios here. I have 9/6, because I can see that 9/6 is easier maybe to scale to 27. So 9 times 3 makes 27, 6 times 3 makes 18. So 18 dozen buttons. And now last problem here, how many dozens of buttons can they buy for $63? So 18 over 12 dozen equals how many for $63? Again, I know that 9 goes into 63. I'm going to go back to that earlier ratio. So I know that 9 times 7 would make 63. So 6 times 7 would make 42. So I have 42 dozen buttons. So again, double check all of your ratios here really carefully. There's a lot of different pieces to look for on each of these answers, and you really want to make sure you're setting up each part just right. Your final problem is about free throws. So Denzel makes 10 out of his first 15 shots, and his success rate stays about the same for his next 100 free throws. So I could think about how this is kind of like a ratio of 10 out of 15 when it comes to free throws. These are his successes, I guess I could say, and his attempts. And so 10/15 is also scalable, right? You might notice here I could make 10/15 equivalent to 2/3, right? If I divided the top and the bottom by 5. I could also scale it up to something like 4/6 or 20/30. So all of these are equivalent, and that might help me figure out some of my missing values here in a minute. So about how many baskets do you expect Denzel to make in his next 60 attempts? So he's getting 10 out of every 15 attempts. So after 60 attempts, I need to find this scale factor here. So notice attempts are on the bottom. So 15 times 4 would make 60. 10 times 4 would make 40. I'm expecting him to make about 40 baskets. How many free throws do we expect him to make in 80 attempts? Well, 10/15 equals what out of 80? Again, these are the ones he's making. These are his attempts. And I'm looking for a scale factor. And again, if I do 80 divided by 15, or 80 divided by 15, I can find that exact scale factor, which comes out to 5 1/3. And so then 10 times 5 1/3 would make 53 1/3. Now, obviously you can't make a third of a free throw. So if you want to say your estimate is around 53 or 54, either of those would be appropriate. So now we're going to do something slightly different. How many attempts will he need to make to get 30 free throws? So we're starting with the same proportion. He makes 10 for every 15 attempts. So if he makes 30 free throws, right, 30 that are good, how many attempts would he need to make? So 10 times 3 would make 30. 15 times 3 would make 45. So we think he'd need to try 45 times in order to make 30 shots. And we have one last one that's just like this. What about if we want him to make 45 free throws? So he makes 10 out of 15. So if we want him to make 45, well, 10 times 4.5 would make 45. 15 times 4.5 would make 67.5. So you might round that up to 68, for example, and say you'd expect it to take about 68 attempts. That's it for your homework. I hope you can correct all those problems and come ready with any questions you have as we keep exploring proportions tomorrow.